Okay, chapter 4.2 types of distributed database systems. Then අපි කලින් වීඩියෝ එකේ කතා කරලා ඉවර කරා මේකේ introduction part එක. දැන් අපි බලමු distributed database types. There are different types of distributed database management systems classified based on the degree of homogeneity. එතකොට දැන් මේ homogeneous and heterogeneous කියන්නේ මොකද්ද? අර තියෙන දේවල් ඔක්කොම එක જાතියේද එහෙනම් homogeneous එහෙම නැත්නම් වෙනත් database engines නම් ඒවා heterogeneous. ඒතර homogeneous කියන්නේ all the sites in the distributed database used identical software and heterogeneous different software. Degree of local autonomy is another factor relevant to the degree of homogeneity. If the local site is not allowed to be operated as an independent site, there is no local autonomy. If local transaction granted permission for direct access to the server, then there is some degree of local autonomy. Classification of DBMS with regards to distribution, autonomy and heterogeneity can be explained as below. Centralized DB got complete autonomy but complete loss of distribution and heterogeneity. Pure distributed database systems, there is only one computational schema, a site, which is a part of the distributed database management system, provide access to the system, therefore no local autonomy. Further classification of centralized DBMS can be done with level of autonomy. Those are federated database systems and multiple database systems. These systems consist of independent servers, centralized DBMS with local users, local transactions and database administrator, facilitating a very high degree of local autonomy. Federated database systems have a global view of the federation of databases that is shared by the applications. Multiple systems have full local autonomy in database but does not have global schema. Example, system with full local autonomy and full heterogeneity, peer-to-peer database systems. Okay. Classification of the distributed database systems that we discussed in previous two slides can be seen in the following image. එතකොට pure distributed database systems ගත්තොත් එහෙම heterogeneity එක සෑහෙන්න උපරිමයෙන්ම තියෙනවා. හැබැයි autonomy එක නැහැ. හැබැයි autonomy තියෙන තැනක heterogeneity නැහැ. Okay. දැන් අපි කතා කරන්න යන්නේ design techniques ගැන. ඉස්සලම fragmentation ඒ කියන්නේ දැන් මේක distribute කරන්න කලින් අපි fragment කරන්න එපයි. කොහොමද මේ fragmentation කරන්නේ? As the name implies, in distributed architecture, separate portion of the data should be stored in different nodes. Initially, we have to identify the basic logical unit of data. In a relational database, relations are the simplest logical unit. They can table and the simplest logical unit. හැබැයි ඒක further fragment කරන්න. Fragmentation is a process of dividing the whole database into various sub-relations so that data can be stored in different systems. Examples. Suppose we have a relational database schema with three tables. මෙන්න මේ tables තුන employee, department and works on. එතකොට works on එක හරහා තමයි මම හිතන්නේ department එකත් එක්ක මේ දෙක relate වෙන්නේ. ඔය කියන්නේ එක employee කෙනෙකුට එක ඒ කියන්නේ department කීපයක වැඩ කරන්න පුළුවන්. multiple ඒ කියන්නේ men to men relationship එකක් තියෙනවා. Assume there are no replications allowed. They can data replications allow storage of certain data in more than one place to given availability and gain availability and reliability. So data replications allow කරන්න හැල්ලු. එහෙම අවස්ථාවක. Okay, ඔන්න tables තුනක් තියෙනවා. employee, works on and department කියන tables තුන. දැන් මේක partition කරන්නේ කොහොමද? නැත්නම් fragment කරන්නේ කොහොමද? Approach 1. One approach of data distribution is storing each relation in each site. They can location තුනක database තුන tables තුන තියාගන්න. හරිද? මෙන්න මේ විදිහට. Approach 2. Another approach is dividing a relation into smaller logical units. For instance, think a scenario where three different departments are located in three different places. ඒ කියන්නේ table එකේ row wise දාන. ඒ කියන්නේ හැම database ඒ කියන්නේ හැම location එකේම table තුනම තියෙනවා. හැබැයි table තුනේම හැම rows ම නෑ. එක එක locations වල තියෙනවා. එක එක ඒවා විතරයි. ඒ කියන්නේ based on transactions අපිට එහෙම කරන්න පුළුවන්, distribute කරන්න පුළුවන්. For the scenario given in previous slide, we can store data relevant to each department in separate site. The details of finance department will stored in one site, blah blah blah. ඒ විදිහට තියෙනවා. ඊළඟට horizontal fragmentation. දැන් horizontal කියන්නේ හරස් අතට fragment කරන. දැන් අර ඒ කියන්නේ එක table එකේ columns එක එක තැන්වල තියෙනවා. Subset of rows in a relation is subset of rows in a relation is known as horizontal fragmentation or shared. Selection of tuple subset is based on a condition of one or more attributes. With horizontal fragmentation, we can divide tables horizontally by creating subset of tuples which has a logical meaning for each of the subset. These fragments are assigned to different nodes in the distributed systems. Each horizontal fragment on relation can be specified in relational algebra like this. අපි බලමු දැන් මේක reconstruction of the logical relation is done by taking the union of all fragments. එතකොට when horizontal fragmentation එකක් කරලා තිනවා employee table එකේ name කියන එක දැන් මෙතන ගත්තොත් එහෙම then if we want to store sales employee details in marketing employee and marketing employee details separately in two nodes on the horizontally එක fragment කරලා තියෙනවා. ඒ කියන්නේ ඇත්තටම මෙතන මේ දෙන්න හරිද sales department එකේ ඉන්න දෙන්න එකකට දාලා තියෙනවා. marketing department එකේ ඉන්න දෙන්න තව table එකකට දාලා tables දෙකක් create කරලා තියෙනවා. horizontally එක fragment වෙලා. හරි. එතකොට මේ දෙක තැන් දෙකක locate කරනවා. Original table is divided into two subsets. First horizontal fragment created like this and second horizontal fragment create like this. එතකොට අර marketing employee and sales employee කියලා fragments දෙකක් හදලා තියෙනවා. ඊළඟට vertical fragmentation with vertical we can divide the table by columns. හරි දැන් අරක ඒ කියන්නේ columns තුන ආවට ඒක ඇත්තටම row wise නේ කැඩෙන්නේ. ඒක අර දැන් මේ horizontal කියන එක ගත්තොත් එහෙම අර table දෙකක් හැදෙනවා කියන concept එක තමයි තියෙන්නේ. horizontally ඒක fragment කරනවා. මේකේ tables දෙකක් හැදෙන්නේ එකම table එක බෙදෙනවා. With vertical fragmentation, we can divide the table by columns. There can be situations where we do not need to store all the attributes of a relation in a certain site. මොකද සමහර attributes access කරන්නෙම නැති වෙන්න පුළුවන්. Therefore, with the technique vertical fragmentation, we can keep only required columns of the relations within a single site. In vertical fragmentation, it is a must to include the primary key. ඒ දෙකේම අනිවාර්යෙන් primary key එක තියෙන්න ඕන. දැන් අපි ගත්තොත් මේ තියෙන්නේ මේකේ primary key එක name නම් හරිද name එකයි salary එකයි එකක තියා ගන්නවා name එකයි department එකයි තව එකක තියා ගන්නවා. එතකොට මෙන්න ඒකේ explanation එක තියෙනවා. Okay, mixed fragmentation කියන්නේ අර දෙකම. ඒ කියන්නේ අපිට ඕන නම් ඒක හතරකට කඩලා දැන් හතරක තියාගෙන ඉන්න පුළුවන්. හරි. දැන් ඉස්සල්ලාම මේක department wise sales and marketing කියලා කැඩුවා. ඊට පස්සේ ඒකේ වෙනම name එකයි salary එකයි වෙනම තියාගෙන ඉන්නවා. ඊළඟට name එකයි department එකයි වෙනම තියාගෙන ඉන්නවා. අන්න ඒ වගේ. එතකොට මේකේ තියෙන්නේ department විතරයි. හරිද? ඒක ආයි horizontally මේ කඩලා තියෙනවා tables දෙකකට. හරි. මේකේ තියාගෙන ඉන්නේ salary විතරයි. එතකොට මේ mixed එකක් තියෙනවා. Okay. මෙන්න තියෙන activity එකක් කරන්න බලන්න කරලා මොනවා හරි ප්‍රශ්න තියෙනවා නම් ඒ activity එකෙන් අහන්න. Okay. ඊළඟට අපිට කතා කරන්න තියෙන්නේ replication ගැන. ඒතකොට replication එක කියන්නේ මොකද්ද? multiple copies එක. කියන්නේ තව copy එකක් maintain කරනවා. The main purpose of having data replicated in several nodes ensure the availability of data. One extreme of data replication is having a copy of the entire database at every node. Full replication or other extreme is not having replication at all. ඒ කියන්නේ මොකුත් නැහැ එකක් ගියොත් එහෙම ඔක්කොම ඉවරයි. ඒ කියන්නේ backup එකක් නැහැ වගේ අවස්ථාවක්. With full replication, we can achieve a higher degree of availability. The reason for this is the entire system keeps running, even only one site is up. Another advantage is improved performance. මොකද ඒක share කරගෙන run කරන්න පුළුවන්. ඒ කියන්නේ එක තැනකින් ආපු query එකක් එතනම run කරන්න පුළුවන්. However, there are drawbacks. එතකොට එකක් තමයි degrading write performance. මොකද update වෙන්න ඕන multiple locations වල, making the concurrency control and recovery techniques are more complex. ඒ full replication. ඊළඟට ඒකේ අනිත් end එක no replication. ඒක when there is no replications, all fragments must be disjoint. But the repetition of primary key should be expected for vertical fragments. එතකොට vertical fragments වලදී අනිවාර්යෙන් primary key එක අපි කලිනුත් දැක්ක repeat වෙනවා. Also known as non-redundant and suitable for systems with high traffic. මොකද traffic වැඩි නම් අපිට multiple ඒ කියන්නේ replications උත් එක්ක මේක distribute කරන්න අමාරුයි. Lesser degree of availability is a disadvantage. මොකද එකක් down වුණොත් එහෙම මුළු system එකම වැඩ කරන්න බෑ. To get the balance between the pros and cons we discussed, we can select a degree of replication suitable for our application. Some fragments of the database may be replicated and others may not. It is also possible for have some fragments replicated in all the nodes in the distributed system. Anyway, all the replicas should be synchronized when an update is taken place. Read කරනකොට වගේ නෙමෙයි write කරන්න ගියා. Allocation. There cannot be any site which is not assigned to a site in DDB. The process of distributing data into nodes is known as data allocation. The decisions of selecting the site to hold each fragment and the number of replicas available for each data depends on the performance requirements, type of transactions, availability goals, and transaction frequency. Consider the following scenarios and suggested allocation mechanisms. Require high availability of the system with high number of retrievals, recommended to have a fully replicated database. Requires to retrieve a subsection of data frequently, recommended to allocate the required fragment into multiple sites. Required to perform higher number of updates, recommend to have less number of replicas because the replicas will not have make update. However, it is hard to find the optimal solution for distributed data allocation since it is a complex optimization problem. Okay. Distribution models. When the data volume increases, we can add more nodes within our distributed database system to handle it. There are different models for distributing data among those nodes. Number one, single server. This is the minimum form of distribution and most often recommended option. Here, databases will be running in a single server. Since all the read and write operations occur in a single node, it would reduce the complexity for the management. ඊළඟ එක sharding. Database can get busy when several users access different data in different parts of the database at the same time. This can be solved by splitting data into several parts and storing them in different nodes. This is called sharding. In the best case scenario of sharding, different users will access different parts of the database stored in separate nodes so that each user will only communicate a single node. These techniques will help in load balancing. It is necessary to segregate data correctly. For this technique to be effective, data that are accessed together should be stored in a single node. එහෙම නැතුව අර මේ එකට access කරන්න නැති ඒවා එක තැනක තියලා වැඩක් නැහැ. The following considerations should be made when segregating or sharding the data. Location. Place the data close to the physical location of the access. එතකොට අර network issues අඩු වෙනවා. Load balancing, make sure that each node will get approximately similar number of requests. නැත්නම් එක node එක විතරක් load එක වැඩි වෙනවනේ. Order of access aggregates that will be read in sequence can be stored in a single node. Auto sharding is a feature given by most of the NoSQL database where the responsibility of splitting and storing data is given to the database itself, ensuring data that goes to the correct shard. Sharding will improve read performance as well as write performance, improve read performance by replication, and improve write performance by horizontally scaling. It is hard to achieve reliability only with the use of sharding. To improve reliability, it is necessary to use data replication along with sharding. Otherwise, even though the data can be accessed from different nodes, a failure of node can make shard unavailable. එතකොට දැන් මේ database එක distribute කරනවා කියන එක නිකන් ඔහේ කරන්න බෑ. ඒක හරියට බලලා ඒ scenarios අනුව තමයි ඒක distribute කරන්න ඕන. ඊළඟට master slave තුන්වෙනි type එක master slave replication. In this model, one node is selected as master. ඒකේ ඔක්කොම data ටික තියෙනවා and considered as the authorized source of data. Master is the node which is responsible for updates. All other nodes are treated as slaves. There is a process called synchronization and to sync data inside master with the slaves. Master slave model is suitable for a system with read intensive data set. ඒ කියන්නේ multiple locations වලින් read කරනකොට speed එක වැඩි කරගන්න පුළුවන්. හැබැයි write කරන්නේ එක තැනකට ඒක ඊට පස්සේ අනිත් ඒවාට update වෙනවා. By adding more slaves, you can increase the efficiency of read operations. However, there is a still limitation of writes because only master can process the writes. Writes අඩු තැනකට ඒක ගැලපෙනවා. If the master fails, it should be recovered or a slave node has to be appointed as the new master. Appointment of the new master can be either an automatic or manual process. That disadvantage of having replicated nodes is the inconsistency that may occur between nodes. එතකොට එකක තියෙන data නෙමෙයි අනිත් එකේ තියෙන. එහෙම ප්‍රශ්න ඇති වෙන්න පුළුවන්. If the changes are not propagated to all the slave nodes, there is a chance of different clients who are accessing various slave nodes read different values. එතකොට ඒක හරියට update උනේ නැත්නම් එකක තියෙන update එක නෙමෙයි අනිත් එකේ තියෙන්නේ. එහෙම දැන් financial transactions එක යන වෙලාවක එහෙම වුණොත් සෑහෙන ලොකු ප්‍රශ්නයක් ඇති වෙනවා. ඊළඟට peer to peer replication. In a master slave, the master is still bottleneck and a single point of failure. මොකද master එක fail වුණොත් එතන update ඊළඟට කරගන්න බැරි වෙන ප්‍රශ්නයක් ඇති වෙනවනේ. In peer-to-peer model, there is no master and all the nodes are equal weight, of the equal weight. All the replicas can accept writes. Due to this reason, there will be no loss of access to data due to failure of single node. However, in this model, we have to accept the problem of inconsistency. මොකද එක තැනක update එකක් අනිත් තැන update නොවෙන්න පුළුවන්. After you write one node, two users who are accessing that changed data item from different nodes may read from two different values from two different nodes. One solution for this inconsistency problem is ensuring that the coordination between replicas to synchronize with all the nodes after performing a write operation. Another solution would be coping with inconsistent write. Combining sharding and replication, we can use both master-slave replication and sharding together. In that approach, we have multiple masters, but there is only one master for each data item. Also, we can combine peer-to-peer replication and sharding. A common application of this can be seen in column family databases. Okay, එතකොට activities දෙකක් තියෙනවා. මේ දෙකක් කරන්න. ඊළඟට 4.4 එක අපි ඊළඟ lesson එකෙන් බලමු.